Introduction to Apache Kafka. Okay, then let's just start. So, Apache Kafka. Kafka is a high-performance, real-time messaging system. It is an open-source tool and is a part of Apache projects. The characteristics of Kafka are: it is a distributed and partitioned messaging system. It is highly fault-tolerant. It is highly scalable. It can process and send millions of messages per second to several receivers. So let's just look at Kafka history. Apache Kafka was originally developed by LinkedIn and later handed over to the open source community in 2011. It became a main Apache project in 2012. A stable Apache Kafka version was released in February of 2015. Use cases. Kafka can be used for various purposes in an organization, such as messaging service. Millions of messages can be sent and received in real time using Kafka. For real-time stream processing, Kafka can be used to process a continuous stream of information in real time and pass it to stream processing systems. For log aggregation, Kafka can be used to collect physical log files from multiple systems and store them in a central location such as HDFS. For commit log service, Kafka can be used as an external commit log for distributed systems. For event sourcing, a time-ordered sequence of events can be maintained using Kafka. Now, Kafka data model. The Kafka data model consists of messages and topics. Messages represent information such as lines in a log file, a row of stock market data, or an error message from a system. Messages are grouped into categories called topics. Example, log message, stock message, etc. The processes that publish messages into a topic in Kafka are known as producers. The processes that receive the messages from a topic in Kafka are known as consumers. The processes or servers within Kafka that process the messages are known as brokers. A Kafka cluster consists of a set of brokers that process the messages. Now, what are topics? A topic is a category of messages in Kafka. The producers publish the messages into topics. The consumer reads the message from topics. A topic is divided into one or more partitions, and a partition is also known as commit log. Each partition contains an ordered set of messages. Each message is identified by its offset in the partition. Messages are added at one end of the partition and consumed at the other. Now, partitions. Topics are divided into partitions, which are the unit of parallelism in Kafka. Partitions allow messages in a topic to be distributed to multiple servers. A topic can have any number of partitions. Each partition should fit in a single Kafka server. The number of partitions decide the parallelism of the topic. Now, partition distribution. Partitions can be distributed across the Kafka cluster. Each Kafka server may handle one or more partitions. A partition can be replicated across several servers for fault tolerance. One server is marked as a leader for the partition and the others are marked as followers. The leader controls the read and write for the partition, whereas the followers replicate the data. If a leader fails, one of the followers automatically becomes the leader. Zookeeper is used for leader selection. Now, what are producers? The producer is the creator of the message in Kafka. The producers place the message to a particular topic. The producers also decide which partition to place the message into. Topic should already exist before a message is placed by the producer. Messages are added at one end of the partition. Consumers. The consumer is the receiver of the message in Kafka. Each consumer belongs to a consumer group. A consumer group may have one or more consumers. The consumers specify what topics they want to listen to. A message is sent to all the consumers in a consumer group. The consumer groups are used to control the messaging system. Now, let's look at Kafka architecture. Kafka architecture consists of brokers that take messages from the producers and add to a partition of a topic. Brokers provide the messages to the consumers from partitions. A topic is divided into multiple partitions. The messages are added to the partitions at one end and consumed in the same order. Each partition acts as a message queue. Consumers are divided into consumer groups and each message is delivered to one consumer in each consumer group. And Zookeeper is used for this coordination. Brokers. Brokers are the Kafka processes that process the messages in Kafka. Each machine in the cluster can run one broker. They coordinate among each other using Zookeeper. One broker acts as a leader for the partition and handles the delivery and persistence, whereas the others act as followers. Brokers receive the message from the producer and sends it to the consumer groups. Now, Kafka guarantees that message sent by a producer to a topic and a partition are appended in the same order. A consumer instance gets the message in the same order as they are produced. Persistence in Kafka. Now, Kafka uses the Linux file system for persistence of messages. Persistence ensures no messages are lost. Kafka relies on the file system page cache for fast reads and writes. All the data is immediately written to a file in file system. Messages are grouped as message set for more efficient writes. Message sets can be compressed to reduce network bandwidth. A standardized binary message format is used among producers, brokers, and consumers to minimize data modification.